right, everybody, today we're continuing with Chapter 1, Section 4, Extrema, and average rates of change. Now, what we're going to be doing right now, yesterday we talked about relative minimums, relative maximums, absolute minimum, absolute maximum. So before we begin, let's do a quick little review. All right, so in your journal, all right, what's that mean? Did I gave? I don't know. Or did somebody else give me? All right, let's just pretend that didn't happen. All right, I'm not going to take up the cell phone yet, but if it happens again, I'm taking it up because I don't want to pause this video. All right, so we have an x, we have a y. Now I'm going to draw some function. Okay, so it looks like this. All right, what would I call this point right here? What could I call that point? Okay. Maximum? Yes, that is a maximum. But I'm going to make, can anybody be a little more specific? Relative maximum. Relative maximum. I'm not going to tell you where that is because I did not put little tick marks in for the x and the y. However, what about this point right there? Yes, that's a maximum. We want to add a word to that to make it a little bit more specific. Absolute. You're absolutely correct. That is the absolute maximum. That is the highest that it actually gets. It does not get any higher than that. So that's the absolute maximum highest point. Okay? Now what about this guy? It is a minimum. But what we call that actually it's a relative minimum. There is no absolute minimum because this graph, the left-in behavior, where is it going? It's going to negative infinity. What's the right-in behavior? It's also traveling to what? Negative infinity. All right, so it looks like this. We have 3 critical points right here. These are called critical points. All right, what could we call this critical point right here? Yes, that is a relative minimum. Good. Relative minimum. All right, what about this one?
Absolute minimum.
You're right. It is an absolute minimum. You're absolutely correct. All right, and what about that guy right there? Relative maximum. Good. Because technically there is no absolute maximum because the right-in behavior is going to positive infinity, and the left-in behavior, that's also going to positive infinity. Okay? So you guys need to know what these mean on this assignment and for your quiz tomorrow. You need to be able to identify those. Okay? So now what we're going to do, everybody, is we're going to look at average rates of change. Now you should have this formula in your journal already. We're going to check number 2. So everybody get your graphing calculators. I want you guys to type in this equation in your graphing calculator. Mr. Lewis, could you look at your paper and tell me what that is when I turn mine on? I'm going to print this out, get y equals. I know it starts with x cubed. What's after that? Plus 5x squared? Minus 7x? Minus what? 4. Minus 4. Alright, let's take a look at this graph. Let's graph it. See what it looks like. There it is. Okay, let's check our table, and we're going to change our window settings. Alright, over here in the negative area, it looks like it gets all the way up to, say, a 40. Okay? So hit the window button. Let's change that sucker Y maximum. Let's go all the way up to 50 so we can see it. 50. Alright, oh, I'm going to turn my grid lines on. Second zoom. Let's go over here and change these to grid line. Okay? Turn your grid lines on. Hit graph. Oh, I don't like all those tick marks. So let's go to window settings. Let's change your Y scale. Instead of 1, let's go 10. That's a little bit better. Maybe go evaluate from what? From 1 to 3. So here's what I want you guys to do. I want you to label this. This is your first x value. This is your second x value. This will always be the smallest. This will always be the biggest. This is the interval that you're going to be evaluating the average rate of change. There's the interval that we're going to be doing. So where x is 1 to where x is a 3. So I'm going to go back. Right here, this is where x is a 1, right here. Because remember we said x scale. So my x value is right there at a 1. My y value is down here towards, looks like just a -5, around that. Now if we go to 3, 1, 2, 3, and go all the way up to where it touches the graph, there's your other point. So what we're going to be doing on this graph, everybody, what we're going to be doing is we're going to be finding the rate of change that goes through this point and this point. What kind of slope does that appear to be?
A very steep one.
Very steep one. Positive or negative?
Positive.
Positive. So we're going to have a very, very, very steep positive slope. That's what we should get. Okay? So right now, our formula is this. You're going to take the function of where you evaluate your x2 value, and you're going to take away what f of x1 is, and you're going to divide it by x2 minus x1. And that is going to be the slope of SEC. You guys remember what SEC stands for? Yeah. That's going to be the slope of your what? Of your secant line. That's going to be the slope of your secant line. Now, if you were going to do this by hand, everybody, this is what you would have to do. Okay? I'm going to say f of x2 right here. And f of x2, you would do open parentheses, plus 5, open parentheses squared, minus 7, minus 4. And what would you do? You would take this 3 and you would plug it in and evaluate it when your x value was equal to a 3, because that's your x2 value. And you would do the exact same thing for your x1 value, for your first x value. And your first x value happens to be at a 1. So you plug in a 1. Plug in a 1 there, a 1 there, a 1 there. And you evaluate it. But what have we already done in the calculator? We've already typed this equation right into the calculator. So what can we do without having to type it all in like this? Oh, yeah, go to your graphing calculator, take second graph, and we're going to evaluate it when x is a 1, right? Right here, where x is a 1, and where x is a 3. So when x is 1, what was our y value? -5. When x is 3, what's our y value? 47. So let's go back and remember that. Okay? -5, 47. Okay, so all of this ends up equaling a 47, and all of this ends up equaling a 5, right? So let's use this formula right here. Oh, it's -5? Good job, thank you. So we have f of x of 2, or x2. So right here we're going to put a what? We're going to put a 47 minus. What are we going to plug in right here for our x1? We're going to plug in -5. Very good. All divided. What was our second x value? It was a 3, right? And our x1 was the number 1. Okay, so we have 47 minus a -5. That's going to change that to a plus, and what are we going to get? What's 47 plus 5? 52. Good. Okay. 3 minus 1 is 2. So our average rate of change for this secant line ended up becoming the number 26. Now what does that mean? That means this sucker is going up 26 units and going just to the right once. Why did I draw the graph and draw the secant line on the graphing calculator for you to see before we did all of this? Because if we just solved for the number and said it's 26, we wouldn't know what it is. Go back here to see how the picture. Oh, there we go. So this slope right here, the slope, the slope of the secant line ended up being 26. That's a really steep. So this section to this section, I have been on a roller coaster in Orlando, Florida at Universal. I think it's the Rockin' Sea roller coaster. When you go up, you literally go what feels like it's just straight up, like your back is turning. Yeah, you're like, oh my goodness. And then that sucker goes down like that. Okay? It's pretty fun. Okay? Yeah. So everybody, that's how you find your average rate of change. Change. So right now, let's go over to our assignment. All right, we've done 1 and 2. Let's go to the back page. I want to make sure you guys understand what I'm asking you to do. Okay? So we're going to look at this right here. And it says, use the graph of each function to estimate intervals to the nearest 0.5 unit on which the function is either increasing, decreasing, or staying constant. So what we're going to do is, I want you guys to type this equation into your graphing calculator, if you would, please. Okay. I'm going to change I'm going to hit zoom 4. Okay? Change my graph here. Alright, so I think we have x to the 5th. What's after that, Brandon? Minus 2x cubed. Okay. Minus 2x cubed minus 2x squared minus 2x. Oh, what I forget to do, everybody? Forgot to hit the right arrow. Dadgummit. It's okay. Let's go back here. Now we'll hit the right arrow. So it's minus 2x squared. You can learn a lot by watching other people make mistakes. You don't have to do it yourself. The graph. There it is. Okay? Now, it looks like all of your windows actually go from -5 to +5, and your y values also go from -5 to +5. And I'm going to make that square. There we go. So there's everything squared up. So right now, I'm going to highlight some things. Oops, not that. So right here, I'm highlighting from here to right there in one color. I'm highlighting from here to right there in another color. I'm going from here going up. All right, look at the blue section right here. What do you guys think is happening in the blue section? From left to right, put your pencil. Yeah, so this right here is definitely what? Increasing. Okay? What's happening right here? That's decreasing. And then right here is increasing. Alright? So, where is it increasing from left to right? Where are you starting? You're starting where? You're starting at negative infinity, and it's increasing from negative infinity all the way up to where? To 0. So here's what you would do. On your paper, you would say, it is increasing from negative infinity. And why do I do a soft bracket? Because I'm not what? Not including negative infinity. And by the way, you are also not going to include 0. You're not going to include 0 because it is increasing all the way to 0, not including 0. And then what are we going to do? We said it's decreasing where? Yep. So decreasing from 0 to, let's kind of estimate it. If this right here is at a 1, and this is at a 2, what would we say that is right there? So you know what? It says estimate what? The nearest half of a unit. Let me show you what you guys can do to figure out where that is. Go go to your graphic calculator. Okay? We're going to figure out how to figure out exactly where that is using the graphic calculator. So what I want you to do, I want you to hit second trace. And is that area a minimum or a maximum in the graph? It's a minimum. So go to number 3. This is where it gets a little bit interesting. On your calculator, you'll see that it says left bound. All right? So anything on the left side of that is considered a left boundary. So I'm going to actually get it a little bit closer. So if you hit the right arrow, you can see how you get your cursor a little bit closer to that minimum. I don't want to go past it. Is this still on the left side of that minimum? So I'm going to press enter. Look what your calculator does. What does it create? It creates a nice vertical line to let you know you created a boundary. Now it says what? Right boundary. Well, where do you want the right boundary to be? On the other side, right? Okay. At this point, is it technically on the other side of that relative minimum? Sure. Press enter. So now, right here, you see what? 2 vertical lines, and our minimum is technically right there, right? That relative minimum is right there. So here's the cool thing. This calculator is now going to, check this out. Sweet. Check this out. Now, where is our approximate value of our relative minimum? We're at a what? 1.34, right? And we're at negative 4 point, we'll call it 0.8. So if I said round it to the nearest hundred, this would be the ordered pair. That would be your x value and your y value for your what? For your relative minimum. But it said what? It said estimate to the nearest what? 0.5. So let's think about this. 1.34. Is that closer to 1 or is that closer to 1.5? I'd say it's closer to 1.5. What's the perfectly between those? 1.25. So since this is closer to 1.5, what I want you to do on your paper, what's it decreasing from? From 0 to what we're estimating is a 1.5. Now technically, what did we get? We got a 1.34. Does that make sense? All right. Now from there, it goes what? It goes up. So it's increasing from where to where? It's increasing from 1, we're going to call it 1.5, even though technically it's 1.34, to where? To positive infinity. From right here, going up, it's just going, it's increasing forever. So we found a place where it's increasing, a place where it's decreasing, and another place where it's increasing. All right? What I need to do is I need to pause this real quick. All right, we're going to head down to number 5. All right? What I'd like you guys to do is we're going to type this equation in right here. And it says what we need to do is we need to classify all the extrema for each graph of the function. All right? All right, so go to the graphic calculator, hit y equals. We're going to type it in. Peyton, I'm going to look over your shoulder here and make sure I get the right graph. It's x to the 4th, right arrow, minus 3x squared plus x minus 5. I go ahead and graph. Now, here I'm going to change the window. It looks like we go all the way down to a negative 12. I'm going to change the window here. I'm going to go x minimum is negative 4, positive 4. Y minimum was, say, negative 12, positive 12. I'm going to count it by 4s here. There we go. That looks a lot better. Okay. Okay, before we do this, you guys can put this on your paper too. We have a point right here. I guess I'll change colors. We have a point here. We have a point right about in here. And then we have a point right there. So we have 3 critical points that we're estimating. What is this point right here going to be called? What are we going to call that point? That's the absolute minimum. So we're going to have an absolute minimum, okay? Right here, what is that point going to be called? Yep, relative maximum. And here we have a relative minimum. So you're going to have how many answers? You're going to have 3. There's 3 critical points right there, all right? So what we're going to do is we're going to do one at a time, everybody. We're going to do one at a time. Second, trace. We're going to calculate number 3, which is a minimum. I want you to scroll over to the left side of our absolute minimum. We're going to round our answer to the nearest. There we go. Press enter. Now I'm going to go to the right-hand side. By doing this, you're getting good practice on how to use the graphic calculator to help you. Press enter. So here we have it, right here. We're at 1, negative 1.3, comma, negative 8.5. Now, where's negative 1.3 closest to? Negative 1 or negative 1.5? Okay, so here's one of your answers, everybody. I want you to write the absolute minimum, all right, is where x is what? X is equal to a negative 1.5. And where is it at? The absolute minimum is at where? A negative 8.5. So your ordered pair would just be negative 1.5 and negative 8.5. All right, so if you put this right here, that ordered pair, and say absolute minimum, that's fine. Okay? This is your y value, and that's your x value. I'll do one more. Okay? Let's do this relative max. Okay? Let's do the relative max. So I'm going to clear this out. I'm going to hit second trace. You go to 4 now. Okay? I got to go all the way over here. This one's going to be a little bit trickier, so I got to be careful as I'm doing it. All right. I would say this is definitely on the left side of my maximum. But now what I want you to do is, as you're doing your cursor, make sure your cursor starts to go down. So right now it's going up. It's staying pretty constant, it looks like, even though it's not. Now it's finally going what? It's going down. So I'm going to press enter one more time. And our maximum is somewhere in between here. Okay? Sweet. It's right there. So it looks like right here is our what? Relative maximum. So right, relative maximum. We're just going to put an ordered pair. Okay? What's this x value closest to? 0.5 or 0? 0. 0. We're going to put 0. So that's closest to 0. We're going to round it to the nearest half of a unit. And what's negative 4.9 closest to? Negative 5. So there you go. Relative maximum. And that's what you do again. You do one more time for this. This is what? This is a relative minimum. So once you come up with that answer on your own, hopefully you have enough to be able to finish this on your own. Good job. See you later.